Okay, so thanks for joining. Today we're going to talk about chapter 2.4 and chapter 8.1. So we're going to kind of combine two of them real quick. So this is talking about conic basics, and what a conic is. Um, Let me kind of share with you here what a conic is. So I'm imagine if we were to take two cones and we were to stack them on top of each other. Okay. And then we're going to take a piece of paper or just a knife and we're going to slice these cones into specific directions. So maybe I slice my cone in that direction. Well, if I cut that, then I just get a circle. If I cut it, look at the cross section. Let's say I cut it like this, going through just one of the cones. Um, then I will get an ellipse, or what you call normally an oval. If I cut it this way, we'll get a parabola, and in that case, it actually go down. And then if I cut it through both of them, I get what's called a hyperbola, which is just two parabolas connected. So we're going to talk about equations of all four of these and kind of generalize some properties with all four of those. Um, so let's first talk about a circle. So we're going to kind of define a circle. A circle is the set of all points equal distance from a fixed point called the center. Okay, so graphically here, if I can find a pin, there we go. So if I have a fixed point right here, and I have, let's say, I take a string and I go a fixed distance and I just swing that circle all the way around, that would create a circle because each one of these points on this circle is that fixed distance away from that one point. Okay, a parabola is the set of all points equal distance from both a line and a point. Okay, so let's say I have this line here, right there, and I have this point. Let's say I've got this point right here. Okay, so I'm trying to find all the points that are the same distance from here to a point in here. So let's just start. If I go halfway between, okay, so from here to here is the exact same distance as the line to that point. Okay, now if I come out here, let's say to, I don't know, here, okay, so this distance should be the same as this distance. And we said this one was the same as this one. Then I'd come over here and I'd say that one's the same as this one, and this pattern continues forever until I get a parabola. So I'm saying that this distance here to here is the same as this distance. Sorry, it's perpendicular to that line. So all these are 90 degrees. So those distances are the same. Okay, and here to here to here. all the same distances. Okay, so parabola from a fixed point and a line, the equal distance. So an ellipse is the set of all points this one gets kind of tricky. The set of all points whose sum Okay, so the set of all points whose sum of the distance between 2 points is constant. Okay, so for an ellipse, we need to start with 2 points. Okay, and imagine I were to tie a string between these 2 points, and let's just say it's like that. I'm going to stretch that string out and I'm going to swing it around. So then I will get something that might look something like that. Okay, so if I take this distance and this distance, I will get a constant number, whatever number that is. So it's d1 and d2. If I take d1 plus d2, I get some constant. So then if I swing this string down here and take those two measurements, so let's say this is d3, d4, I will add those two together and I will get the same number. That's what it means by constant. No matter where this string is, even if the string's right here, I'll take this distance plus this distance. So that's d5, d6. I'll add those together. I'll get the same number. Okay. Okay, hyperbola. Hyperbola is the set of all points, the fixed distance, whose distance that is a difference, but is a constant. Okay, so the set of all points whose difference between two fixed points is constant. Okay, so just like this, but instead of adding them, we're going to subtract them. So let's say I have two fixed points here and here. Okay, and I take a string between them and subtract the distances of the string. So let's say I'm here and here. Okay, if I subtract D1 and D2, I'll get a constant. Okay, and same thing if I go, I don't know, here and here. It's a constant, and it will end up looking like this. If I keep doing this a bunch of times, it's kind of a bad picture. That should have been on there. But it will end up being two parabolas, or what we call a hyperbola. I definitely need to do a lot more test points with that, but you get the basic idea. So we have a very general formula that will give me all of the it's one formula that will give me all the shapes, and the formula looks like this. Okay, so each letter means something and does something, and we'll talk specifically about each shape. Okay, so if it was a circle, A is 1, C is 0, C is 1, and B is 0. Okay, so this will go away. And so you'll have A is 1, C is 1, and you could have numbers for these three. Okay. For an ellipse, for a parabola, and for a hyperbola. Now, all of these correspond to what's called the discriminant. And we talked about that when we talked about parabolas. The discriminant can also tell you how many imaginary or non-real solutions that you have. Well, it also tells you if it's an ellipse or a hyperbola. And notice I have B is right there. All these letters are in here. I got C, which is right here. Okay, so all those letters we're just looking up there to see how it falls into these formulas. We also, so I use this to determine what kind of, so I could give you a random equation that looks something like that. Like, let's say I give you, for an example, I give you that equation right there. I'm going to use these, I'm going to use these 4 items in this equation to determine what form this is in. Okay, so if I look back here, okay, a goes with x squared. So in this case, capital A is 1 over a squared. Okay, and then I have c, which is y squared. So c is 1 over b squared. And f is my constant. So f is -1 because you got to move it to the other side. So then I would use these to determine which one of these. Now, we could go in with the other letters, like capital B is 0, capital D is 0, E is 0. Everything else is 0. So if I plug it in, obviously it's not going to be a circle because A is not 1, C is not 1, B is 0, but it gets rid of the circle. So then I would find b squared minus 4ac. Is that bigger than 0? Is that equal to 0? Or is that greater than 0? And I'd have to see what that might be. Okay. Now, we have specific equations for each one of these. So I'm going to go ahead and, usually I don't give these out right away, but I'll go ahead and give you these so that we can kind of look at them. Now, these are very straightforward equations. We'll get into more detail about the equations later on. Remember, we can shift these things up, down, left, right, stretch, shrink, all that kind of stuff. But these are the basic equations for each one of these. So a circle, we have x squared plus y squared equals r squared. And r is our radius. Okay, an ellipse, x squared over a squared plus y squared over b squared equals 1. Now notice if we go back to the definition of an ellipse, we are adding the distances between the two. That's why you have this addition sign. So hyperbola is going to be very similar, except instead of addition, it's going to have subtraction between the two. And then with a parabola, okay, parabola is just with anything, anytime x is squared. So we might have like y equals x squared. That's a pretty basic parabola. We could also have If we wanted to get more letters in there, we might have y equals x squared plus x plus 1. I mean, that could be a parabola. It could have x's and y's. Those could be together. It just can't have it. It can only have the x being squared. Okay. So there's a lot of things we can do with these. I'm going to stop right there because that was a lot of definition work. Okay, I first want to show you your suggested problems. Note that it is chapter 2.4 and this is chapter 8.1. Okay, so you've got quite a few problems here to work through. And then here are your questions. So what creates an ellipse? What is the equation for, and I'm going to change that to a hyperbola. How do I know what a conic equation makes? How do I know what conic the equation makes? So if I give you a random equation, how do you know which one it is? Okay, that is it. You can stop right here. If you want to continue and watch, I'm going to go through some different examples of problems. Thanks for watching. Be sure to like and subscribe, and we'll continue on. Okay, so we know kind of the definitions. So let's go back, and if I give you some equations. So I gave you this equation here. And we said what kind of shape that was. Now, you already know what kind of shape that makes, that it's an ellipse, but let's look at why. So we go through all the letters. Okay, and we look at all these. So a is with x squared, so that's 1 over a squared. B is 0, and I'm looking back at this right here. Okay, so B was with xy. Well, there was no xy. C is with y squared, so that's 1 over b squared. D is with x. I don't have that. E is with y. I don't have that. F is your constant, but I got to set this equal to 0. So if we move that over, I get -1. So then we want to look at, is it a circle? Well, no, because it doesn't follow those. Then is it an ellipse, parabola, or hyperbola? So we got to look at the discriminant. So we want b squared minus 4ac. 4ac. So b is 0. That's 0 squared minus 4. A is 1 over a squared. C is 1 over b squared. Okay. Now, if we're going to assume that a and b do not equal 0, because I can't divide by 0. Okay, so those are not 0. So these are non-zero numbers, and they have to be positive numbers because we're squaring them. So even if a is -1, -1 squared is still positive. So all these are positive. So you have 0 minus 4 times some positive number times some positive number. So this could be like 0 minus 20, or it could be 0 minus 4 over 20, or something like that. So no matter what numbers I have in here for a and b, as long as they're not 0, this will be less than 0. Okay, and since that discriminant is going to be less than 0, this is an ellipse. Okay, so let's try another one here that is very similar. So let's say I just change that sign. Okay, now I just changed this sign, so that only changes what c is. So now c is negative 1 over b squared. Everything else stays the same. So you still want b squared minus 4ac. Okay, so that's 0 squared minus 4, 1 over a squared, and negative 1 over b squared. Okay, again, a and b can't be 0. Now, this negative and negative, those cancel each other out, so I get positive. So this is like saying 0 plus 4 times some positive number times some positive number. No matter what you put in there, this is going to be bigger than 0. And since it's bigger than 0, it's going to be a hyperbola. Okay. Again, we will get into more detail with those. We want to talk a lot about a circle here. Okay, and the equation we want to know for a circle is this right here. Okay, so H and K is the center. And the radius is R. Okay, so we could give you some formula here. Let's say I give you this. Okay, well, this tells me it's a circle, x and y are squared. You got nothing else. This is the same thing as 2 squared. Okay, now, because it's in this form, it's also Pythagorean theorem. So you get a square plus another square equals a square. That tells you it's a circle as well. Your center is at 2, 1. Again, the 2 is the x value because it's with the, oops, sorry, you can't see. The 2 is the x value since y, so it's the y. And your radius is 2. Okay, so when I go create that circle, we're at 2, 1, and my radius is 2. So I'm going to go 2 this way, 2 this way, 2 this way, and 2 this way, and create that circle. So all of these points along this line are the same distance from that point right there. Okay, so it could get a little harder, and it could be something like this. So find the center and radius of this circle, and it gives you something like this. Okay, I have to get it into this form right here. Okay, in order to do that, we're going to complete the square with both the x's and the y's. So we're going to have x squared minus 8x plus blank plus y squared plus 20y plus blank equals negative 107 plus blank plus blank. How do I figure out what goes in the blank? That's the b over 2 squared. So I have negative 8 over 2, which is negative 4 squared is 16. So we'll put a 16 in both of those. And then you have 20 divided by 2 is 10, squared is 100. So we'll put 100 in those. So when I factor these x's, you get x minus 4 squared plus y plus 10 squared equals 9, which 9 is 3 squared. So my center is at 4, negative 10, because that's usually a minus there, and your radius is 3 because it's the square root of that number ending right there. Let's see here. Let's look at one more real quick. Okay, so the points 10 minus 4 and the center is 7, 8. I want the equation. So this is the point on the circle and this is the center, and I want the equation. So we'll start off by saying this. So I know the center is, so that's a minus 7 and that's a plus 8, but I don't know this radius here. So I need to find the distance between these 2 points right here. So distance equals the square root of subtract your x's, so 10 minus 7 squared, plus subtract your y's. Okay, and we've been doing this formula for a while, so that's a square root of 10 minus 7 is 3, squared is 9. 4 plus 8 is 4, squared is 16. 9 and 16 make 25, so that is 5. So this is 5 squared. Okay, so this is the center with radius. If I wanted the general, I would have to multiply all this out. So this right here is the general formula for a circle. Just like we had, where'd it go? This general formula right there. Those match. Okay, again, here are your questions. That's really it. On 2.4 and 8.1, it's just knowing what ellipse, like what the conic sections are, and a little more detail about the circle, which you should already have. So here are your questions. Here are your suggested problems. Make sure you go through those, take a good look at them. And if you got questions, let me know. As always, this is at THS Mr. Jones signing off.